Well, hi, good morning. It's the second day of November. Another day to work on this little radio. So this radio's performance is getting pretty close to what I would expect it to do. And if its performance were 100%, maybe we're at 85% of what it can do. I don't really know for sure. But I think what might be interesting to do next is to take a look at these two capacitors. The original capacitors which the previous repairer left in. So I think it'd be interesting to take a look at what these two capacitors are doing, ask ourselves why he didn't bother changing them, and then, should I go ahead and change them, or are they really inconsequential for some reason? They should just be left. These other capacitors, this guy and this guy, even these two big filter capacitors, there's some other ones, another one down here, a couple, a ceramic one the fellow put in, whoever it was. What condition are they in? So here's one of the capacitors that this fellow put in. Other than being kind of dirty on the surface, it looks to be in very good shape. This one was in a critical location where even a small amount of leak through it can present a problem, seemed to be presenting a problem in the radio. This was the grid blocker for the output tube. Is this indicative of the condition of these other capacitors? This looks like a junk box capacitor. It looks like something that came out of another radio before it went in here. Is that really the story? Gee, I don't know. What should I do? I want to do the least. I want to do the least I can to this radio to make it operate. But I really think we should look into these two, because I think the most curious question is, why didn't these two get changed? What is it about them that the last repair guy, who obviously knew what he was doing, didn't bother with them? So we can start with this one. This is the easiest one to find on the schematic, so let's go check it out. Well, this turned out to be a little more interesting than I would expect. So the radio I've got, I'm just going to look on the back of it here again. CL541A. So you can see here it says CL541A. There's another schematic here on the sheet. This is only for the 541D. But look, when we look for that capacitor that's obviously involved with the antenna, this is probably the capacitor here. If you notice, well, this is showing a wire antenna, like a long wire antenna. The D is showing a loop. But this radio I got in front of me has a loop antenna. It has this kind of antenna. But it certainly says A. It says 54A. But there's no question it has this antenna. Or another loop antenna. What to make of that? Other than that, I imagine everything is the same. I'm just taking a quick look at tube lineup. I think everything is exactly the same. I mean, the radios look very, very similar. This looks a little different here. Not really, no. How about here? Different size, 0.2. Well, we don't know. We don't know because these values aren't labeled. So I've been scooting down and using this schematic just to get the part sizes. Well, it looks like the major difference is the antenna here. Okay, if we look here, we find this capacitor. This is probably what we've got here in this radio. So basically, the radio has a contained loop antenna. It's contained on the inside of the radio where you cannot touch it. There is a terminal on the back for hooking up more antenna wire if you wished. That would be this. Either this is the connector or this is a symbol for the antenna, and the connector's here. And there's the capacitor. What's it here for? Shock hazard. I would say it's here to protect someone who's going to be hanging on to this antenna while they hang it up, or move it around, or do whatever. while this radio is plugged in. I mean, it's a very high likelihood that would happen. With an unpolarized plug, there's a chance. Watch. See this B minus line here? Is this for sure the B minus? Yeah. This could be 120 volts AC on it. You touch it and get a shock. You're out in your backyard with your wet sneakers, hauling your antenna around. And the connection through this capacitor, through the loop, out this wire. This is a smaller capacitor here. My guess is this size capacitor is not enough to protect you if you're out hauling the antenna around, stomping in your backyard with bare feet or something. And the smaller capacitor is there for that purpose. Reduce the amount of current that will flow. Of course, the current coming out of your outlet is at 60 cycles. That's a far cry from the radio frequencies that this radio is looking for. So the power transfer, I don't like to talk about it that way, but would be greater for the higher frequencies through this capacitor. It'd be limited if they've sized this right. Very limited for a human being hanging onto this wire. I think this is a safety capacitor and not much else. I don't think changing it would change the function of the radio unless the capacitance has disappeared and this is now an open circuit. But look, it's an open circuit to an outdoor antenna. Who's going to hang an outdoor antenna on a radio that already has a loop? Not me. So this capacitor is unimportant for the operation of the radio. And I think that's how the person who did this work would have concluded that. Now there's another capacitor. As far as I know, every other capacitor is quite important in here. But let's take a look. We'll look at the radio and try to identify the location of the other capacitor. Okay, so this is the one we just looked at. Here's the one that's kind of in the middle of the radio. You can see one lead going up to a terminal on this coil. This is pretty sure to be the local oscillator coil. A coil or transformer. There's the other winding down here that's involved with the local oscillator. You can see the outside foil line is down here. I think I can see the connection. This radio is not plugged in. I say quickly looking over. It is actually plugged in. It's not plugged into a source of power, but that's even better like that. It sure looks like the bottom of this capacitor is connected to this terminal right here. This terminal is not grounded. So maybe this terminal is grounded in some way. A little hard to see up in there. Looks like there's another wire coming to it. This looks like 0.05 is the capacity here. This one should be 0.005, but I don't see it. But you can see it's physically a little bit smaller than this one. So we follow the yellow wire. Oh, it's heading up to the antenna. You see the tug on the wire. And you can see it's this wire coming up. I thought that was a capacitor there again, but it's just a piece of wax that's broken off here. So we have, on this we have two terminals. The center terminal is riveted. The rivet's sitting there, but it's not connected to anything. So you could touch this, you're not touching the radio. Likewise, all these staples that are coming through, you can touch them all. Even these screws, as I pointed out earlier, these screws are going into wooden blocks to provide isolation, so you cannot touch the chassis. This is the whole idea. If I remember right, these knobs were sticking out. And these shafts were sticking out of the cabinet, and these are not, they don't have a collar on them. So later radios, these wouldn't protrude out of the cabinet. They'd actually be recessed, and there'd be a collar on the knob to reach in. And that was so that you could pull the knob off. You still wouldn't immediately touch this. You'd have to stick your finger in the hole, and at that point, too bad for you. If that's what you're going to do. This terminal has a resistor and then the capacitor. Wait a minute. So resistor coming here. Very light wire here going back to the loop. Okay, I'm pretty sure that's, well, this is a little different, is it? Maybe. Well, you know what I'm thinking of? I'm thinking of what I saw on the wire antenna. But this is the loop antenna. But this is still supposed to be associated with the wire extension. We have it come from here through a resistor to this terminal. Then it would look like a light wire, which is part of the antenna coil. We'll look at that again on the schematic when we get back to it, because it's not quite clear to me. I like things to be clear. Otherwise, mistakes are going to be made. So this guy comes here, and this goes up to the antenna. I have two capacitors associated with the antenna. Let's go back and take a look again. Two capacitors associated with the antenna. So here's the one. Where's the resistor? There's a resistor up here. Yeah, this is the loop antenna. L3. Doesn't sound like it. Well, how do you like that? It's L3. So there isn't a lot of difference here. So this is the loop antenna. This is the main antenna here, loop part. Well, this would make sense. This would add up again, and we're back on the 541A. Okay, so my misinterpretation, this is a loop antenna here. Okay, that all makes sense. Now the other one was somehow associated with the antenna. So if we look, there's one here. And so C6A, let me zoom in on this a bit here. C6A and C6B. So the A and the B indicate to me that this is the actual tuning capacitor that's hooked up to the knob. And these are trimmers on the capacitor, this being the oscillator and this being the antenna. So none of that is the capacitor. It's connected to this one of these wires. Well, this has to be it here, C8. How big is C8? 0.05. That's exactly what we've got there. This is not an unimportant capacitor, I'm pretty sure. Let's just follow this wire here. Well, this takes us over to the detector with its two plates. So what's happening here, a little hard to understand what's right in there. But it looks like one diode plate is involved with producing the audio, which is going to go into the volume control. I should say revealing the audio, which is going to go into the volume control. The other one appears to be involved with the what? So that's a suppressor grid. That's normally tied to the cathode or something of that sort. If you're going to place, oh, okay, so never mind that. Let's follow it down here because I've already done that. It goes up here. Here is where the AVC voltage developed on this diode can be placed on the grid. Okay, following that. Don't know what they're doing here. Clever engineers figure little tricks out, and then they want to, sort of proprietary approaches to things. For some reason, putting the suppressor grid here is making some sense to somebody. Somebody did it. So we follow this back even further, bearing in mind there's a DC voltage on here, the AVC voltage, and can it get to the grid of this tube? That's what we're trying to find out. Come up through here, run around in the antenna, eventually come out here, come up, and number 8, that's the signal grid right there. So the AVC voltage is applied, as it is in most of these radios, to the first and second tube. If there was an RF tube, it might be applied to that too. So this AVC line, and this is the B minus line down here, and in between is this capacitor. So we could call this the AVC capacitor. Could also be in charge of draining out any signal that might be here, audio or otherwise. Could easily be a bit of audio on it or RF on it coming out of this tube. So now I'm saying these things, this is what's in my head. Could I have this wrong? Sure. I don't think I'm far wrong. I might be leaving something out. I don't really know. Interesting. Here they didn't put the gang dotted line in, but on this one they did. And this one has an extra capacitor out here. But not this one. These trimmers are rather limited. They go pretty much from 0 or close to 0 up to maybe 10 or 15 picofarads, not much more. So this is probably a booster. So this thing's ranging between 10 and 25, this combination here. Not that we need to worry about it. Okay, so why not change this capacitor? Why leave this one? I think this is a fairly important one. If the capacitance is gone, which is not very likely, but if it had no capacitance, this was just open here, you won't drain this properly, and you probably get motorboating and feedback and weird stuff happening. I'm not sure if that's true. I guess we could disconnect this and find out what happens to the radio. The other thing it does is it provides a signal ground back to the B minus, the gain. If the capacitance is lost, that's not going to work well. And you get bad performance in this transformer, I would say. Why leave it? It seems like an early target, if you like, to change. That's an interesting question. Maybe there's oversight, but it's pretty easy to see that capacitor. It's sticking right out there. Well, while I wouldn't worry so much about this guy, this one really needs to be dealt with, I think. So we're going to go after this one first, and we'll see what's happening. Now the radio's building an AVC voltage. We can see it happening. Maybe what I'll do, I can do a couple things here. One is I can set up a stable test situation on my bench, and we can read the AVC voltage. When I change the capacitor with everything the same afterwards, fat chance on that, but we'll do our best, and see if the AVC voltage has changed given a certain signal going through here. That's these kinds of experiments in my shop usually fail for one reason or another, but we can try that. Another one is we can chop this guy out, turn the radio on, and see what happens. If there's absolutely no connection here, I think we'd have a screamer of a radio. I could also put in a undersized capacitor, but why bother? Just take it right out. That sounds like an interesting thing to do. What happens if this capacitor is a dud? Maybe, these capacitors can go to zero if the lead breaks off inside the capacitor, so there's no connection between the capacitor lead and the guts. That happens. That's how you can get that situation. Yeah, that sounds like an interesting thing. I don't think it puts the radio at risk at all. Just my reputation, that's all. Since we're talking about capacitors and leaky capacitors and what can happen, this is my oh so wonderful military grade signal generator. Works for me wonderfully. Never done anything to it except turn it on and use it. And it works fine right now. The output is fine. The problem is this meter. Not the meter itself. This meter right now is showing modulation. Okay, so let me just set this back. Wow, the output was way off calibration. So what I've just done is I've calibrated the output that's going into the multiplier here. And so I set it to 10 microvolts. If this were set to times 1, it would be 10 microvolts coming out of here, supposedly. That's great. So that's a usual process. After you dial in the frequency and the band and all, get it set up, you then double check this to make sure it's at 10. So this calibration makes sense and you have some notion as to how much is coming out of the signal generator. Flip it back to here. This is now on modulation, showing a little under 20% modulation, so we really want it up around 30, something like that. Now what will happen here is, as I'm working away in my shop and the clock is ticking away, and this thing's been running for 20 minutes, 30 minutes, an hour, this meter will just start going higher and higher on the scale until finally it's pinned up against here. There's nothing you can do to bring it down. Doesn't matter what you do, it's pinned. What I think is happening is that this meter circuit is probably isolated from the rest of the signal generator, and there's probably a tube stage in there, and the tube stage is driving the meter. That's my guess. Not necessarily like that, but it could be like that. And that there's a capacitor in there that has high DC on one side, and maybe the grid of that tube that's driving the meter on the other. Over time, a little charge is going through the leaky capacitor, and it's building up on this side, on the grid side, making the grid go more positive, making the current flow go higher, making the meter go higher. The real kicker for this, or the thing that really makes this make sense, I'm not saying it's true, I don't know that it's true, it's just my theory at the moment. So when I switch off the power, the meter stays pinned. There's no power going to it. The meter stays pinned for maybe 3-4 minutes, and slowly drifts back. Well, that couldn't be the effect of a grid, could it? Because once the power's off, the tube will shut down moments later, and there'll be nothing going to the meter. So my theory went out the window already. But still, a leaky capacitor is a very likely cause of what's happening here, only it's not in the position I'm guessing at. I've never really looked at the schematic. This is quite a beast. I'm not anxious to open it up, so I'm kind of limiting my operation with it to around an hour, or when I notice that this meter's gone and gotten pinned. Don't like that. I suppose in the long run it's possible to burn the meter out if there's just too much going through it. Once the meter gets pinned, you can't tell if it's pinned hard or pinned soft. You just can't tell. And my assumption would have to be it's just getting worse and worse and worse all the time. So a little anxious about that, because I do like this signal generator. It's very, very reliable. I switched it on this morning, and I left it at 1 million. It came right up on 1 million, just like that. It doesn't drift in or drift out or anything. It's really a nice signal generator. So, and I have some modern replacements, like a very modern replacement, and the thing issues a ton of radio interference, so I don't even have it in my shop. I use the old guy. Yeah, using the old guy in more ways than one. So that's just a little talk about leaky capacitors, and maybe it's affecting my instrument there. And what have I done here? So I've turned on the radio to warm it up. Oop. Let's go full. I didn't turn on the radio. I turned on the power, but not the radio. Okay, turning on the radio. I want this to warm up a bit before I do this. Okay, and we're watching for some AVC action over here. The radio should be tuned around 1,000,000 for this to work. And you know what else I need to do? I need to get this. If I want to stabilize this, I'm going to go right in on this clip here. So we're going to go, should we go to the chassis and the clip. Is there any other ground? Oh, Jim, hold it. I already have a meter ground here. So I think we're going to ground the same place. I'm going to go on here. No sparks flying. Hey, that's a valid technique. See if anything blows up. I'm not the only one who practices that technique. Okay, so we don't hear anything now. We have a fairly strong signal coming over here, modulated at 30% with 400 Hertz. Watching the meter here. What does the meter say? Not particularly strong. There's the reading. 5-volt scale. So I'm going to write this number down. I'm going to write that number down, then I'm going to go drink some coffee, let some time go by, and I'm going to come back. As soon as I find, where's my piece of paper here? Super piece of paper. And see if it's drifted. So, voltage right now, it's pulsing. It's pulsing ever so slightly. Now, that could be because there's another signal, interference signal. We can't really hear it, but I don't know if you can even see it pulsing. Just slightly. Doesn't seem to be drifting upwards, though, by eyeballing it. So this is just about exactly 5.6. 5.6. 5.6 minus 5.6 volts. Okay, we'll leave that running and I'll come back in a few minutes. Hey, why don't we do the same thing with this meter? I'm going to put this right on 30, so it's gone up a little bit. 30. Do I have to write that down? Can't I remember that? 30% is what that is. Okay. Coffee time. Okay, I think it's been about 10 minutes maybe. So, first of all, let's see. We've gone from 30 to 32 over there on that meter. Slowly rising. This one's dropped down from 5.6 down to 5 scale. 5.6. Jim, you got the wrong scale there. It was really not 5.6. That's okay. You know, I'm just going to read it on the wrong scale anyway for comparison. It's down to 3 from almost 6, so it's about half. But probably it's because the radio tuned itself off. So I'm going to tune the radio and see if we can get it back up. Ooh, going higher. Now, did I actually tune this radio to maximize it? Maybe I didn't in the first place. I get it right around 7. Okay, it's not really 7. It's actually 2.4. No, 2.2. It's actually 2.2. We're going to do this again then. 2.2. That's why I mentioned when I started this that doing these quantitative experiments in here usually go sour for one reason or another. We're watching one go sour right now. But let's try it. So I still have some more coffee to drink. So, okay. just leave it all sitting here. Okay, let's see how the experiments are going. How's my signal generator doing? So it's gone from 30 to 35 now on this meter. And I believe it's just the meter. It's not the machine itself. The output is remaining the same. But I guess I can't be too sure about the percentage modulation with the meter being like that. Okay, how about this guy? So it was up at 7, or 2.2. It's now at 2. Let's use the right voltage. 2 volts. Okay, so tuning again. And it's drifted again. That's kind of interesting in itself. Okay, we got a little more than 7 this time. If I'm lucky. Here we go. Okay, so it's returned to 7 as I retune the radio. So I think 7 or 2.2 is the number. 2.2. Okay, so we'll consider that to be the way it is. Now I'm going to nip out that capacitor. I don't think I want to do it with the radio operating. Let's get a little volume on here. Let me tune this a little bit. Trying to make sure the meter matches what I'm hearing, and of course it does. A little bit of backlash in the tuning. There we go. Whoops. Come on. I seem to get it back to 7 now. Okay, just about 7, just about 2.2. Cutter's ready. Power off. Now, which end should I nip? Well, this is the only one I can get at easily. So we're going to nip it here. Okay, so the radio is now going to operate with no capacitance in that position. I think it's going to make it oscillate. And I think it's going to probably disrupt the automatic volume control. So this voltage level would be different. I think we're ready. So I'm going to put it on lower voltage to start. For some reason. Oh, that's all we need, I think, right there. Listen to that. This gone high because this capacitor was leaky and it was drawing it down. It couldn't produce this voltage. Question of the week. Can we tune anything? What happens if we tune that? Or we touch this thing at all? It turns into a... Why would it be like that? Why would it be so sensitive suddenly? Is it this capacitor itself floating around in here? Wow, you know, I could hear this kind of thing and think, oh, there's something loose in this radio, and go off in search of something loose. Maybe there is something loose in here, when in fact it's because this capacitor is disconnected. I wonder if that's ringing, where I'm causing a disturbance because I'm touching the radio and shaking it a bit, and that disturbance is setting up a feedback. But instead of persisting, it's collapsing very quickly after a few cycles. So we hear kind of a chirp. No, I'll take that back. I can make it sustain here. Oh, I don't know what to make of that. I don't know what to make of that. Where's the tone? I'm going to change the voltage here. Where's the tone from the signal generator? I'll try tuning the radio. gone away. And where's this hum coming? Okay, we'll shut her off. I didn't even put full voltage on it, ever. Supply voltage. Would have been close though. Well, that's interesting. That's one sick puppy. All because of one capacitor there. Okay, I'm going to cut out the capacitor for real, and I'm going to put a new one in, and then we'll see what happens here. In the meantime, I'm going to just click off my signal generator to relax this voltage, which is just slowly climbing up, and it will eventually go right off scale. Give it a chance to relax for a little bit. It's such a good signal generator. Oh, look what it did. The meter went right over. Now it's coming back. It's a good signal generator. When I flip it back on, it will come back to the same state it was in, regardless of that meter. Very good. Okay. Change the capacitor. Yeah, I just cut out the one that was in there. And while I was doing that, I was thinking, as I was shaking the radio a little bit, that there's wires hanging here that are associated with the radio and this whole thing. And maybe just doing this is actually causing those wires to vibrate a little bit. And that's where some of this funny noise is coming from. Basically hanging parts that can move a little bit in there. So here's the capacitor taken out. So look at the end. The end seal looks, well, doesn't look perfect, but doesn't look terrible. And some of the wax has kind of gone away here and here from being laid up against the part. And then, you know, these things warm up in the long run. That's got a bit of warmth in it. Let's put it on the tester. Let's put it on the tester. Let's see what's happening here. Just fiddling with my camera. Sometimes the lighting can be very helpful. Okay, right there. That's not terribly good, is it? Struggle with this all the time. Okay, so I'll just tell you what's happening with the pi here, because it's just so hard to see. Oh, there, that's not, well, no. The camera keeps compensating. 50 volts. What do you say? So it opened up just about all the way on 50 volts. 150 volts. Not happening. So I've tested hundreds of capacitors this way over the years. This one would rank as a bad guy in some positions, for sure. The leak would be significant. In other positions in the radio, a little bit of leak might not mean much, but the particular position it's in, I'm not sure. But it's tired. It's tired. So I'm going to put in a new one in its spot, and then we're going to look at the test results and just see if we can draw any conclusion at all. You know, and sometimes, by the way, when you're doing this kind of stuff and you think you're targeting this or you're targeting that, and along the way something totally unexpected happens, and then the learning comes. The learning. So painful. Okay, here's a new angle. So looking at my capacitors, most of those yellow ones are brand new. This one's brand new. This one's not brand new. Whether this has been in a radio or not, I'm not sure. Judging from the leads being cut short, probably has been, but maybe not. It looks very much like the one I removed from the radio. And what did I do with it? It's rolled away somewhere. Can I put this one in? I'd like to use it somewhere and say goodbye to it, and rather have it sit in my tray forever. But now I have a way I can test this and make a judgment on this. We'll go back to the tester, which I accidentally left on, but turns out to be a good thing to do. How will this capacitor test? Now I can tell you periodically I put brand new capacitors in here just to keep myself honest. And you can run the voltage right up to the top, 450, and that eye will pop right open. There's zero leakage in a brand new capacitor. What about this one? What about this one? 50. There we go. Right open. Went kind of quick. 150. Right open. This is a 200 volt rated capacitor, so we're going to give it 250. Right open. Now we got to raise a question here: is this capacitor? Is it open circuited? Is it false capacitor? The leads are going nowhere, or does it have some capacity? Having seen that there's no leak, and having given a little bit of time to discharge this capacitor, because when the switch is relaxed, it puts a short right on the capacitor to discharge it, we can try to measure its capacitance. 0.05 should lie right on this band here. Now what I do is I rotate this until the eye opens. That's right in here. And now we're going to take a look. What does the meter say? I'm going to slide this out of the way. 0.05 right there. Wait, that's dead on. So no leak, proper capacitance. This guy's going in. He's going to start his tour of duty in this radio. Very good. Very good. Well, while my soldering iron's warming up, let's check something else out. Do the big filter capacitors in the power supply retain enough voltage to give me a lift? I had my fingers in here and started thinking, I'm right near these capacitors. Is there anything in there that's going to cause me to yelp? Let's find out. Is there anything left in these capacitors? That would be a 0 there. Whoops. And the other one. That would be a 0 there. No, there's nothing left in them. Now I had the set turned on. Perhaps if I turn the set off, that might trap some charge in there. It's not something I normally concern myself with. I certainly know it's standard procedure to discharge those capacitors before working on a radio. It's something I'm really delinquent on myself. But just seeing my fingers so close there. Okay, so what I've done is I've temporarily supported the capacitor in position using this clip lead to hold it so I can solder one end. To get one end soldered, the other one's a lot easier to work with. So we're going to try to do that right here. Occasionally when I'm doing scare myself. When I'm doing this, sound will come out of the speaker, which is a little scary moment too. I don't think I'm getting this soldered very well here. I'm very jumpy. Probably again, anybody who does this work develops the same jumpiness. Once in a while I get a little nerve twitch in my fingers or my hand. I have no idea what it is. I'm sure it's just something everybody experiences. But it imitates an electric shock a little bit. I don't want to spend time considering, gee, am I getting electrocuted here? I end up jumping like a wild man sometimes just from a little feeling in my finger. There we go. That's definitely soldered on there. And I doubt I'm alone with that. Especially when there's critical things going on. Okay. I'll get the other end soldered up. We'll test out this radio. Okay, got the capacitor in place. Let me connect my meter back up right here. Okay, on ground. stabilize it a little bit. Okay, we're good to go here. Switch on my equipment. Here, watch my signal generator. Watch the numbers. It's set for 1,000,000. Boing, 1,000,000. Can you see that? You can barely see that, but it says 1,000,000 right on the money. Amazing. Okay, meter's connected. Scale is 15 volts. The old reading was 2.2 or 7, depending upon how you're looking at the meter. That was my tube checker getting turned off. My tube checker, capacitor checker, getting a few flip leads out of the way. Let's power them up. Dim bulbs in case I boobed up. Looks like no boobage. Watching the meter, listening for sound. Oh, plugging the radio in. There we go. That's better. Thought something was going wrong here. Okay, dim bulbs report nothing. Good. Full power. Watching the meter. So we don't hear the tone. It's probably because the radio's drifted a little bit off. Leave it here for a few minutes, it'll probably drift in, but we can find out what's really happened here. Because I can change my signal generator and I can return it to where it came from. Let's go hunting. $987. Put it back. I have recharged my coffee cup. I'm going to go work on that for a bit. We'll just let this guy sit here and we'll see if it returns to the frequency it was on before or what happens. Don't touch anything. Well, it's only been about 5 minutes. It didn't even make it to my coffee cup. Instead I pulled out the Bible of radio servicing that I have. Anyway, I have many books on radio servicing. This one goes deeper than most. If we look at this diagram quickly, we can spot a capacitor called C28, 0.05, and it's essentially doing exactly the same thing as the C28, as the capacitor in here. C28. This is the AVC line, and it's grounding it back to B minus is where it's really going there. So what do you say about C28? I found it in a table here. A couple of times it's mentioned. C28. No reception. All voltage checks are normal. Open AVC bypass condenser C28. It appears again right here. Weak signal. Open AVC bypass condenser C28. Squeal or oscillation. Different things. Open AVC bypass condenser C28. So with this particular radio, oscillation was the problem. It wasn't weak reception a bit of the problem too? Hard to say, you know, when you judge these radios, when you're fixing them and they start working, it's hard to say without doing extensive gain tests and other things to kind of really prove the radio's really working. Well, it's got to have warmed up now, and it sure appears to me that it just has not returned to the same tuning point where it was. So I'm going to tune the radio, we're going to watch the meter, let's see what happens here. 5-volt scale to get the meter in the same place as it was. .1, where it was 2.2 before. So it's basically the same place. I mean, I can't guarantee the signal generator is exactly the same output, or that I haven't disturbed anything here that might throw it off, beyond doing the capacitor. Doesn't seem any different to me the way the radio's operating. But we need to tune in some real stations. So we're going to take this off. See if this... See, even the... No, maybe not. Put this off. Having a little bit of an effect. Get that ground off of there. Oh my. So in my books, this leads to the same place as this. Made that little speech about being jumpy. You just saw it. Oh, this clip lead jumped at me. Well, that seemed to... Well, of course, I disconnected the signal input. That's what I've done. So I can't do that. Yeah, we do it. Yeah, because I want to see the radio operate. Yeah. Just lay it down. I really like to follow a one-hand rule. Use one hand, put the other in your pocket. As soon as I get two hands going, I get nervous. Okay, man. Are you any better? Let's go down. So this station is in Toronto, so I have the radio aimed at Toronto, so to speak. So there's some other stations down there I can try to get. This is 590. .640, nope. 680, nope. Where'd it go? Try for 860. Back to 590. Antenna trimmer. This is tricky business too, because what you're really trying to hear is not the volume of the signal. You're trying to hear the signal to noise ratio, which is tricky. I mean, you know, we're not built for this kind of stuff. Our ears and that. Okay, my assessment here. This trimmer is having to close too tight. Something going on there. Can only pick up the very best station here. 590 is the strongest AM station. The radio's not picking anything else up. That's not very good. It should be able to pick up a couple other signals, even here in my shop. If I took this radio out of here and put it, you know, anywhere else in my house practically, or even outside, this would probably pick up lots of stuff. The problem is it's overwhelmed with noise, and some of the stronger noises are knocking the AVC, activating the AVC, which is knocking down the sensitivity of the radio, making it difficult to pick anything up other than the noises. My options? Well, think about it a little more. Relocate the radio and see what happens in another location. Look for more component reasons that it's not working well. That's not likely, really. Realign the radio, which I really think is where it's at with this guy. So that's tomorrow. Tomorrow we do another alignment, do it very carefully, make sure it's absolutely correct. See if we can get the pointer to point at 590 here when it needs to, instead of where it's pointing now. And we'll just see if we can somehow get the radio working a little bit better. But that's it for today. And what did my meter go to on my signal generator? It's gone from 30 to about 38 or so on here. So, whoop, take a break. That's done. So thanks a lot for watching. I hope you're getting a kick out of this. Probably tomorrow will be the last day on this radio. See ya.